Alrighty, what's happening, y'all? I'm going to go through a couple of the exercises that Miss Matthews assigned to y'all last week, and then I'm going to ask you to complete the remaining exercises. So, Miss Matthews gave an assignment asking you to use the Pythagorean theorem to find isosceles triangle side lengths. That is a very goofy word. Isosceles simply means that you have a triangle with two sides that have the same length. And if you're looking at the triangle that's on the screen now, you see that the side, both sides of this triangle have lengths of x. So those two sides are the same, and that's why it's an isosceles triangle. So we're going to use the Pythagorean theorem. So let's just start with what we know. It's always good in math just to start with what you know and write that down on paper. So I'm going to write down the Pythagorean theorem, which tells us that a squared plus b squared equals c squared. All right, and then I'm just going to plug in what I know. All right, so I'm going to use this triangle here for the Pythagorean theorem. All right, I could use the other one, but this one has most of the information I need already there. All right, I know that this is a right angle right here, and I know that across from my right angle is something called the hypotenuse. And I know that the hypotenuse always belongs to the letter C. There's the Pythagorean theorem can be super confusing because you have A, B, and C, but when you look at this picture, there's nothing that indicates what A, B, and C are supposed to be. All right, but don't stress about it. All you really need to know about these letters is that C belongs to the hypotenuse. All right, so C is actually x. So I'm going to come down here and I'm just going to write x squared. I'm going to put the x in place of C. All right. As far as what are A and B, well, I know that one of my sides is 12, all right? That can go to be either A or B. That's your choice. And then one of my sides, I don't exactly know the length. I do know that this whole length right here is 10, which leads me to believe that half of that is going to be what I need. All right, so the length of this side that we're going to use is actually 5. All right, so I'm going to use 12 for A, and I'm going to use 5 for B, and I'm going to plug that in. So I've got 12 squared plus 5 squared equals x squared. All right, so now I've got everything I need to know to go ahead and begin the simplification process to find out what that missing side is, what the hypotenuse is. All right, so 12 squared is, so basically I'm just going to simplify these. 12 squared is 144. I'm going to add 5 squared. 5 times 5 is 25, and that's equal to x squared. All right, and I can go ahead and simplify this a little bit more. So I've got 144 plus 25 equals 169, which equals x squared. Now I need to find x. So I need to go from x squared to x, and this can be a little confusing if you don't have a lot of practice with it, which some of you probably don't because this is a new skill that you're learning. So in order to find the square root, or in order to simplify from x squared down to x, we need to find the square root of that term. All right? Keep in mind if we do something on one side of the equation, we need to do the same thing on the other side of the equation because it is an equal sign, which means that what's on the right side is the same as what's on the left. So if we do something on the right, we need to do the same thing on the left in order for the equation to remain balanced. All right? So the square root of x squared is simply x, and the square root of 169 is 13. All right? Which looks like that is answer choice A. All right, so that's that example. Let's do one more example. Figure out if I can get there. Let's go to this example right here. This one's a little more complicated because it tells us one of the sides is the square root of 74. And then it tells us that this whole length along the bottom is x. So let's just start with what we know. I know that we need to use the Pythagorean theorem, which tells us that a squared plus b squared equals c squared. All right, so let's just start plugging in what we know. I also know that the c belongs to the, what did we say the c belongs to? Anybody remember? It belongs to the hypotenuse, which is directly across from the right angle. So we're basically going to be finding out information about this triangle right here. All right? Although we want to find out what this entire length x is. All right? So we're going to find out what half of that is, and then we can double that. All right. So right now we know that the hypotenuse is the square root of 74. All right. So we do c squared, and that is equal to, we'll call this a. We'll call this, we'll call a 7, so we'll do 7 squared, and then we're going to call this length right here, we're going to call that b, all right? And we're going to work to solve for that. All right, so we're going to just simplify this down a little bit. All right, so 7 squared, which is 7 times 7 equals 49, plus b squared equals the square root of 74 squared, which is just 74. All right, now we need to try to get this down to where we end up with b equals a number. So the first thing we need to do is we need to get rid of the 49. And the 49 is being added to the b squared, so we're going to use inverse operations, and inverse just means opposite, in order to remove the 49, to get rid of it. Remember, if we get rid of 49 on one side, we need to get rid of 49 on the other side because we have an equation. All right, so we're going to subtract 49 over here so that our equation remains balanced. And 49 minus 49 equals nothing, which is what we wanted, and we end up with b squared equals 74 minus 49, which is 25. All right? So again, in order to solve for b, going from b squared, we're going to have to take the square root. If we take the square root on this side of the equation, we need to do the same thing on the other side of the equation so that the equation remains balanced. And the square root of b squared equals b, and then the square root of 25 is 5, because we know that 5 times 5 is 25. This can be a little bit confusing because I would go ahead and normally say that my answer is 5, because that's what I got after doing all of this math. But when I look over at this triangle and what we're trying to do with it, I know that x is referring to this entire length, all right? And when we found 5, we actually just found 5 for this spot right here. So this is 5, and if this is 5 right here, then we're actually going to end up with x being equal to 10. All right, so 5 plus 5 is 10. So those are two examples of how to use the Pythagorean theorem to find isosceles triangle side lengths. I'm going to post this for you guys and then ask for y'all to complete that assignment. Hope this helps. If you have any questions, please feel free to reach out to me, and hope y'all have a great weekend.